Today we are going to be looking at relations. So let's look at some vocabulary. A relation is a set of ordered pairs so x and y are parts of our relation. Domain is all possible x values, and range are all the possible y values. So domain and range should be reviewed from our last lesson. So we're going to add that into our relations. So here's our first example. We have the set of ordered pairs 4, 3, -2, -1, 2, -4, 0, -4. So this whole thing together is a relation. We can represent a relation in 4 different ways, just listing the ordered pairs, by a table, by a mapping diagram, or by graphing. So we're going to practice doing the 3 ways here. So to make a table, we list out our x and our y values. And we have to keep the point together in one line. So we have 4, 3. 4 is our x, 3 is our y. Then we have -2, -1. Then we have 2, -4, and 0, -4. A mapping diagram is where our first oval here is our x's, and our second oval is our y. And we draw arrows to show which x coordinates to which y. So let's start with our first point. We have 4 in our x and 3 in our y. So we're going to draw an arrow showing the mapping there. 4 gets mapped to our 3. Our next one is -2. We don't have -2 listed, so we're going to write it. And then it gets mapped to -1. Show the mapping. Show the arrow. Then we have 2, -4. We're going to show the mapping. And lastly, 0, -4. But we already have -4, so we don't list it again. We just show the arrow going there. And then graphing, we're going to just graph our points. So we have 4, 3. 1, 2, 3, 4. 1, 2, 3. Put a point. -2, -1. Then we have 2, -4. And then we have 0, -4. And we just graph it. Now we list our domain. Remember, domain is all your x values. So we have 4, -2, 2, and 0. And we list it in these with these squirrely brackets. Same thing for the range. But it's our y values. 3, -1, -4, and we have -4 again, but we do not list them twice. So that is our first example. I want you to pause the video and do this next example. Come back and check your work. Okay, let's look at this one. We have a relation of 2, 3, 2, -1, 0, 3, and -1, -3. So let's make that as a table. So x, y, we have 2, 3, 2, -1, 0, 3, and -1, -3. Now let's represent it as a mapping. So first oval is x, second one's y. We get 2 to 3, so 2 gets mapped to 3. 2 to -1, so 2 gets mapped to -1. Then we have 0, 3, but we already have a 3, so the arrow goes up. And then we have -1, -3. It's mapped. Now let's graph it. 2, 3, 1, 2, 1, 2, 3. 2, -1, Then we have 0, 3, and we have -1, -3. The last thing we do is our domain. That's all of our x's. So 2, 0, -1. And range is all of our y's. So we have 3, -1, -3. Again, do not list the multiple domains or ranges. We only list it once. So let's look at independent and dependent variables. So independent variables are your x values. That's your input. And your dependent are your y values. And that is the variable that depends on the value of another number. So your dependent depends on your independent. So let's look at some visuals here. This first graph represents height of a baseball after it hits. So after it hits, it's up in the air and it's coming down. So we have the two variables of height and time. Our independent variable is time, and then our dependent is height. So the height of the ball always depends on the time. So we need to come up with a way to use words to describe what is happening on this graph. So an example would be a ball is hit at a height, and as time passes, the ball gets to a maximum height. It gets up to maximum height here. The height starts to decrease until the ball hits the floor. So that is an example. You could say multiple different ways, but this is just the gist here. Let's look at the next example here. This is a graph represents the speed of a bus as it travels to school. So our independent variable is time. Our dependent variable is speed. So let's think of this. Speed always depends on the time. So let's try to think of a situation that we could use this graph in by describing it. So the speed, it's at 0 now, so it's at a standstill. And then the speed accelerates. So accelerating up. The bus travels at a constant speed, and then it starts to slow down until it comes to a complete stop. So that's an example. I want you to do the next two. Pause the video and come back and check. Okay, let's check the next two. So this graph represents the price of a stock over time. So the independent variable is time, and the dependent is the price. So the price of the stocks always depend on the time. So if we look at this, a stock has a positive price and it increases and decreases, and it increases at a higher rate than it did before and then decreases some. Let's check the last one. The graph represents a balance between the savings account. So our independent, you guessed it, it's time. Your dependent is your balance of your account. Your balance is always going to depend on the time. So let's look at what's happening here. There's money in the account. Since it's not starting at 0, it has a previous balance. And it's increasing and then stays at the same amount for a while. more money is added into the account, and then eventually all the money is taken out. So that is the lesson on relations. Please reach out if you have any questions.